that's it. Looks great. Nice bit of furniture, living furniture. This is my laser cut pieces for the Lattice to go onto my laser cut LED setup with an Arduino. Basically they're all cut just around about 33 millimeters approximately. This is the 50 by 50, 5 by 5 millimeter that means. Now the distance between each one of these is 30 per meter. It's 33.5. So I've set my lattice up to be 33.5. So each one is going to be in the middle, and I don't have to worry about cutting anything because they can just fit in like that. Just have to measure the distance between each row and the distance along the other way in the X and Y axis. One axis is going to be set by the way it is built, and the other I have to measure, so it works out completely set. To get a full layer I can switch it over and start putting the top on. So I've got that far. Now we put the top in. Bit of force required. Probably have to give this a tap with a block of wood. That works fine. As you can see, the matrix is coming together nicely. Just got to line these up a little bit as you put them in. Don't bash it till you get it in enough so that you know it is actually going into the groove, otherwise you're going to damage the thing. So next one. Okay, that's our finished matrix. I've had to make sure these are all down. A few of them were still setting up a bit, which you don't want. Now we have to work out our strips. That far. So we might as well cut these off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cut along the line. We've basically just got to cut along the line. Okay, so that's one, which is correct. That's going to be my top one because that's got the input lead. What I'll probably end up having is have positive going down one side, negative going down the other, and then we'll just have one input which will run between each one for the data line, backwards and forwards. So I'll go ahead and cut all these up. Okay, overall measurement is basically 331.5. So I'm going to cut a backing piece out of some white melamine, which is going to be 331.5, so 332 one way, but we're just going to make it 330, and the reason I'm going to do that is because on the edge here we'll be able to run our wires up to the edge without having to drill all sorts of holes, etc. So the wires will be coming through the bottom and around the corner and hooking up to the matrix itself. So it'll be going to be 331.5, 332 long ways and crossways, so I can get the bit of clearance on the edge. It's going to be 330. I'll go and cut that now. This is my piece, which is going to be approximately 33.2 millimeters by 33 millimeters. Let's clean up the edges after cutting it. Let's put a bit of MDF with white, which should reflect nicely anyway. Clean all the blurry edges up. MDF's not the best stuff to work with, but it's cheap. .33, 33.2, 33.2, 33. Okay, that's where I want to run Now, we'll probably run these from the bottom. We'll work all that out. Each unit is, say, 33. The width is basically 10 mils. So halfway between there's going to be 5. Half of 33 is 16.5 minus halfway, which is 5 mil. So that's 5 off 16.5 is 11.5 mil. We measured the width, which is 10 mil. Centre to centre is 33 total, so half of that is 16.5. 10 mil, half of 10 is 5, so we've got 16.5 minus 5 is 11.5 mil. So I basically marked up from the bottom 11.5 mil. Then using my compass, I've marked all the other lines up the page at 33 mil, and that's going to be the bottom of the strips. And when you get to the top, we've got this bottom's going to be up around about there somewhere. So I'm going to put the second hand one in first, but to help me align it, I've basically put a piece of straight edge, which is a piece of the MDF. I've lined it up on the line, so I've just used these 2 clips to align it. And when I put it in, just have to be sure that every second one is going the opposite way, because we've got to start from the bottom. It's going to run that way. All these have got arrows, so it's going to run that way, then it's going to run this way, they're going to run that way. So you've just got to alternate the direction each time you run them up the page. And because we've got the wide away this way, we have about nearly a millimetre overlap on either side, which is going to give us room to solder our pieces of wire onto. So basically I will now just clean the surface. We've got an alignment piece, which is just going to align it. We're just going to start at one end and just run it along our edge, straight edge, and do it from there. This can be a trick with these things, this type of stuff, is sometimes just to fold it under like that. So then you can get your first edge aligned against the top, against the bottom, align it all up, and as you work across the page you just pull the strip out from underneath. Just keep making sure that it's up against the straight edge. And keep pulling our strip out, backing strip. Now we just push that down firmly. We're happy with it. And as you can see, that one's probably a bit close, but we can move it across slightly the next lot. Now we've had our first attempt. That one's just about on the edge there, and that one's just slightly over. So the main thing is to try to keep them so they're straight all the way through. I just realised I stuff up. So what you should do is start this from the top and work down. The reason being that this is now going to be in the road as I try to go up the page. So I will move that to the top position. Okay, so best to start from the top. Same thing, just backwards and forwards. Now I have to be a bit careful, because if I had started from the top in the first place I wouldn't have been any problem. So start from the top, come down the page, alternate direction left and right until you get to the bottom. I've got to now work out by the time I get to the top which way this top one's going to be, because I put this one on already. So we'll just wipe down quite well. Just wipe them as we go down, as I just check them to make sure how much overlap I've got in either end. So that one's got a tiny little bit of overlap. So when I put stuff in this end, I just overlap it slightly. Been bending the corners down on these so that it's not sticking up both ends. So bend those down, bend those corners down a bit so that we don't have a bit that's sticking up. Make sure it's pushed up into the guide block all the way through. Now just go back and push them down. I'll just continue on with these, finish it off, and then I'll just test each one of them before I wire it all up, just to make sure. Otherwise it's a fair bit of work to pull them all up back. I'll just put another strip in if I've got any faulty ones. This is with them all glued on, and that's just the matrix just blade over top. Now we'll just go out and take them up and check all the thing and wire it all up upstairs. This is the matrix finished off with the wiring done. As you can see, we've run earth or the ground down one side, and we've run the digital, looped it backwards and forwards, and the other side we've run the positive, which is the 5 volt. So 5 volt on the left, we've run earth on the right or ground on the right, and we've run the digital signal through. Got it set up onto the Arduino here, wired through as per the instructions. So if we turn her on, Arduino boots up, starts doing a few sequences. I've pre-tested all the individual lines before I finish soldering it all together. From there now it'll just run through a few sequences. So now all I've got to do is put the matrix will go on top, the lattice, which is giving us that nice effect. Now all I have to do is we'll be bending all the wires down and putting that into a box. So we're just going to put a frame around it, put it into a box and set it into the box. So basically just set up a frame which is about 64 millimeters around, and depress this slightly, just enough to get, say, a bit of 3 millimeter stuff on the inside. It's just screwed on the corners and it fits in okay. So I turned it over. Basically we have a block in here in each corner which is 3 millimeters down, and we have to put our power supply and everything through the side here somewhere. This will just be put on, screwed down, and the front piece will be glued in position. The board I'm going to be using is a little Nano. I've set it up as per the instructions from Great Scott. I have an extra. This is a switch. The reason I've got that switch is on the inlet on line of the positive, 5 volts, because that's going to be on the power supply. If we need to adjust the change the programming, you've got to disconnect that from there. So if it's going to be inside this case, just have to switch it off and then put your new program on. All I've got to do is get a 5 volt input to go onto there. I haven't got one of those. So it's going to go from the power supply, 5 volt, 4 amps, to negative. Positive is going to go positive to that side. The main reason for the switch is for uploading a new program. So you need to turn that switch off and then plug in USB. So the 3 outputs out of here into the board are going to be negative, positive, 5 volt, and data. Just got to make up a back for here, and this will actually go onto the side. I've got to rebate that so it goes into here, something like that. I've just soldered the 5 volts onto there at the moment until they get a socket. This is running, and this is running the board, set up to get some opaque screen to go over the top of it to diffuse the lights. The hardest part for me is actually the woodworking side of it. So I've recessed the USB switch and the input plug, which is 5 volts. On this side, massive amount of work. I'm going to hot glue this into position, and then I'm going to assemble the rest of the matrix. Glued in the Nano board on the back. Just putting this in. I'm going to glue the 4 corners here. Then we'll place the matrix in, which is going to look like that. I'll adjust that and I'll glue that in about 4 positions. The last piece we put in is the perspex or acrylic, which on the inside has been sandpapered backwards and forwards in 90 degrees, up and down, and then circular. I tried some of the opaque, but it was too dark. I like this because it's a lot brighter. The other one just took too much light out. So this will be glued in the corner as well. Then we'll turn it over and screw the base down. Mounted in the board. This plug unplugged from here. The reason I've got it so it unplugs is if you want to change the program, not only do you have to turn that switch off, but you also have to turn this disconnect this. If not, the 5 volts coming in through here is going to be running through your LEDs and may damage your Uno, because they're just not designed to handle the number of LEDs. So if you're going to do a change of your software or your sketch, disconnect this, turn that off, and then you can you unplug it or whatever, and then you don't have to worry about that, because you can just upload your new sketch. This is all set up now. It's hot glued from the other side. And as you can see, the wiring comes around here. So when the back goes on, I'll be drilling 4 holes in the corner, which will screw the holder back on the screw, so I can take it off to work on the inside of that. So this is a bit of ply, 3mm ply on the back, 1, 2, 3, 4 screws to go into there. Plug a power in, 5 volts going into there, switch him on, turn our light off. And this is one of the sketches that's available. Quite interesting, changing. It's about 5 or 6 different patterns that it does, and it looks like a nice piece of furniture, as well as having nice patterns. Interesting, but as you can see, just hot glued in the corners and underneath, and then the PVC or acrylic is just rubbed on the other side, and that gives me a nice pattern there, which is not too dull, quite bright, but you cannot see the individual LEDs and that are behind. It gives it a nice effect. Power up, light off, and that's it. Looks great. Nice bit of furniture, living furniture.